So today we are going to talk about voltage multiplier circuits. Fine. And it is, as the name suggests, multiplication means if you have got voltage V in the input, and if you need 2 times V or 3 times V, then it will be called as a voltage multiplier, or exactly voltage doubler or voltage tripler. It happens, and we need sometimes different voltages. So designing a different circuit for different voltage is complicated. So this voltage multiplier is an easy way to design circuits which will give you in the output more than the input. For example, if you see the definition, voltage multiplier circuits use a combination of diodes and capacitor to set up the output voltage in the rectifier circuit. Your multipliers are of different types. It may be doubler. In doubler, your output will be 2 times of input. Tripler, your output will be 3 times of the input voltage. And quadrupler means your output will be 4 times of the input voltage. So we will discuss one by one all of them. Fine. Now we are in doubler. As discussed in doubler, our input will be Vm, and you will see that our output we are going to get is 2 times of the input voltage. This is called as a voltage doubler. So we will start step by step. You know, we have got a voltage, and our voltage is like plus minus. It is always changing. So let us start step by step. Let us talk about positive half, or assume that our voltage is Vm. If I will ask you how your diode will behave, so you can say that this diode, this is P side and this is N side. So this diode is forward biased because P is positive and N is negative. As far as this diode is concerned, this N side is getting positive voltage, so it is reverse bias. So the right part of the circuit is like they are not connected. So anyway, since this diode is forward biased, it will behave as a short or voltage here. You know how a diode behaves. If you make it forward biased, it will be short circuit. If you make it reverse biased, it will be open circuit. So voltage here will be 0. In case of ideal, if it is silicon, it will be 0.7 volt, and if it is germanium, the voltage will be 0.3 volt. Now you know how a capacitor behaves. There will be a voltage developed across the capacitor. If we don't know the value, so let us assume it is Vc. Now how much will be the voltage Vc? We can know by using KVL, or Kirchhoff's voltage law, in the slope. So let us use KVL. Start from this point. We can say that it is minus Vm plus Vc. Since diode is present but it is forward biased, voltage ideal voltage is 0, so we neglect that. There are no other voltages, so it will be 0. The purpose of this equation is to find out how much is the value of Vc. If you will simplify, you will find that voltage Vc equals to, take this Vm on the opposite side, Vm. So this voltage will be Vm. So we have got a voltage like this. Fine. Now this is the voltage, but as I was telling that our input signal is having positive and negative, this voltage will change and it will become minus, and this will become plus in the next half cycle. In that case, you see this diode P is getting opposite voltage, so it is reverse bias or it is open circuit. As far as this diode is concerned, this is N and this is negative, so your diode D2 will be forward bias. Now this, think about this bigger loop. We have got a bigger loop now, and we want to know how much is the voltage here. Let us assume it is VO, because we will collect our output here. Now how much is this? You can calculate by KVL in this big loop. So let us start here, and we will start from this point. Make sure that your voltage is this polarity. So if you start, it will be Vm, then the voltage in the capacitor is plus Vc, or sorry, plus Vm. Just solve it before some time. This diode is forward bias, so that D2 is forward bias, so short, so no voltage, plus VO. Plus VO. All the voltages is what? As per Kirchhoff's voltage law, all the voltage is zero. Now why we are writing this? We want to solve how much is the output voltage. So simplify it further. This VO will be, all the voltage will go to right, so it will be minus Vm. Minus Vm means minus 2 Vm. We are getting minus 2 Vm. That is why we say this circuit as a voltage doubler, because its output is double of the input voltage. Input voltage was Vm and output voltage was 2 Vm. In this way, we have designed a voltage doubler. Similarly, this is a step-by-step explanation of what we have just discussed. During positive half, D1 is on or conducts, D2 is off because it is reverse bias, capacitor charges to Vm, and we have solved it by KVL. Now if you go to negative half, the things are opposite now. D2 is now switched off because it is reverse biased. D2 conducts means it is on. So capacitor C2 also charges to Vm. Now if you put KVL, you will find that finally output is 2 times of input voltage. Hope it is clear. If you have any questions, you can ask me in the comment section and I will explain this. Now again, we are talking about different multiplier circuits. It includes doubler, where output is 2 times of input, and now we are in tripler circuit. As you can see, here is our input. It is Vm. If you will collect your output between these 2 points, when these 2 points means this point and this point, your voltage is 2 Vm, or you can say this is like a doubler. Now if you calculate your voltage between these 2 points, your voltage is 3 times of input voltage. That is what is called the tripler. And if you want 4 times of input voltage, collect your output here, and it will be 4 times of input voltage. That is what is called as quadrupler. As far as its working is concerned, is very simple. Always start one by one. Just analyze how your diode will behave, forward or reverse. If it is forward, make it short and calculate the voltage in the capacitor. How you calculate? Use KVL. Once it is done, your input voltage is always changing. This is very important. Before it was plus minus. Now when we'll in the next cycle, it will be opposite, minus plus. When you have minus plus, now this diode is off and this diode is on. Now you have got a bigger loop. Okay. Again in the next loop, it will be again opposite, like plus minus. Now this diode will be off, and this is the loop we are having. And always use KVL in the loop, and you will see the how the voltages are changed. So this is a circuit for multiplier circuits. These are very general circuits. If you have any questions, you can ask me in the message and we can discuss. So I think that is all about this chapter. This chapter in which we studied